What did you say?
Yes, I say we are about to discuss programming. Would you like to give it a try?
Programming is the process of in the computer instructions or
Hmm.
type or typing something on the computer
Okay,
so it performs a specific task.
okay, exactly like that. Yes, exactly like that. In the general point of view, that's how we could define the programming, as in giving it instructions. But as a computer scientist and a software developer, when they give you such a definition, you might not really see what it includes, what it involves. What does it imply?
Please say it again.
I say, as a computer scientist and as a programmer, when they give you such a definition, it doesn't bring out all the elements that are required in programming. You don't actually see the programming inside. Yes, we give the computer instructions and everything, and it follows it. But how do I give it instructions? What are these instructions? Is there any particular standard of instructions? Do I need to know something special, or anyone can just sit down and then give it instructions? Where do we give it instructions? So you see, the question is kind of, the definition is kind of light. Okay,
Can,
it is breaking again, eh?
yes, please.
Your network is worrying you. It is worrying you. Can you hear me now? Hello, can you hear me?
Yeah, I can hear you.
Okay, let me even try to understand your setup. So you have your hotspot on the from the phone, right? And
Yes,
you
please.
connected it to the PC.
Yes, please.
Wow, it should be fine.
Mm. But now I think it's fine.
Yes, I wish you can stay like that. I'll be happy. Okay, so I was saying that when we define programming as giving instructions to the computer so that it can carry them out and so on. So I was saying that this definition is light because it is meant for uh, children to, or let's say people who don't want to understand deep the computer, to really have an idea of what programming is. But as programmers, we need more than that, right? We need more than that, because when they tell us is to give the computer instructions so that it can carry them out, we need to know what are these instructions, how is that done, where do we go and give it instructions, what what exactly do we use and call it instructions. So all these questions rise for us as programmers. We cannot just interesting. I'm just noticing something on my secondary screen, and it's cool. Okay, so we cannot just say it is like it's that. We need more. So that's what I'm trying to say there. So from my upcoming book, right? I have given four main definitions of programming. Okay. The first definition is that programming is the exercise or process of writing programs. Okay.
Yeah.
Programming is the exercise. The reason is because the word programming is from the verb to program, and then we have it in the gerund form, so which shows the a process of doing something, the process of performing something. So to write the programs, so the process of writing programs is programming. Okay, So it's like you saying swimming is the process of you going to swim, like it's the process of swimming, right? So that's the first layer of the word programming. It's a process of doing something, in this case doing the writing of programs. Sorry. So programming is the exercise slash process of writing programs. That's the first definition. I don't know if you are getting the meaning of that definition. Okay.
Yes, please.
Good. And then the second definition we can say about programming as computer scientists is that programming is the process of automating solutions to problems. And this is where, yes,
Sorry. For the first one, is it just the process of writing programs? That's all.
yes, programming is the exercise slash process of writing programs.
Okay.
Yes. You see, each one of these definitions comes as in a layer of understanding, a level of understanding. Okay. If you would give this definition to someone who has no idea of computers, and so it might look impossible to understand. But once you start to understand computers deeper, like we are doing now, then it will make sense. It will make sense. You know that yes, it is a definition of programming at a given level. Okay. So, and you can see that the second definition tries to go a little bit deeper again by saying programming is the process of automating solutions to problems. You could realize when we were discussing the CPU and the ALU, we mentioned something like arithmetic and logic unit, right? Which carries calculations and so on. So the reason why it carries calculations, which also constitutes some of the advantages the computer has over human beings, is one, the capacity to do something super fast. Okay, the speed is very important. The CPU can do it so fast, and secondly, it can carry a huge amount of information or calculations at a time. Okay, so size of calculation, it can do a lot of calculations in a short time. And then the key part, which is the automation we gain out of that CPU operations. What it means is this: if you have a formula which is let's say let's take any equation like this. So if you have a problem, and then the solution or the function of that problem is 2x, right? So if the function is 2x and we found out that the solution to our problem is 2x, okay, then we don't need to do that anymore. We just have to program that in the computer, and then anytime we need this solution, the computer will just carry this operation. So we have just automated our solution. It's just like this software we are using right now to draw. Somebody sat down and think of a problem and then came up with a model of the problem, one solution or a set of solutions, then give it to the computer, and then once it is automated, it is done. So the process of taking a problem and then producing a standard form of it, or a model of the problem, which is going to be automatically carried out by a computer for any subsequent use or needs, then this process is also called programming. And when you start your computer science class, you have that a lot. So you'll be given so many mathematical problems to automate, so to write programs for them. Okay. So like this, y equals to 2x, over time we can ask you to write a computer program that solves this problem, or that actually models this problem into a solution or a set of instructions that the computer can carry anytime we want it. So if you want 2x to be calculated, you just have to ask computer redo it again and redo it again, because you already wrote the program. So that process of automating situations or modeling situations into standard programs that computers can carry is called programming. Please, if you are not getting me, let me know.
Please, can you repeat the definition again?
The definition says programming is the process of automating solutions to problems.
Okay.
Yes. It is the process of automating solutions to problems.
Okay.
Yes. And then the third definition says programming is teaching computers to do things we do or can't do. Did you hear that?
Yes, please.
Programming is teaching computers to do things that we do or things that we can't do. So, like you were mentioning, some of the characteristics of the CPU or the computer in general, which is speed, for example, we do things, some of the things, such as calculating 2x. So if this equation was to become complex or large enough, it is something we can do, so we can still submit it to the computer to do it. But it can do it better than us. So something we can't do about this problem is to do it so quickly. Okay, it can do that very quickly. Also, there are some problems, they are so huge that we can't do it. So for example, if we ask you to model the weather, it is impossible because you can't predict every single parameter about the weather, but the computer could try to do that. You see, it could try to do that. So there are so many problems that we do, then we write programs for the computer to do them as well, like our daily routines and most of this software we use, like creating documents and Excel sheets and so on. But there are other things as well that we can't do, but we teach the computer to do them as well. Are you getting the point of this definition?
Yes. Yes.
Exactly. So as time goes, we'll go deeper into them and see what it actually involves. Okay. Then, and the fourth definition I gave was that programming is a zoom in, analysis, and confirmation in bracket conformity checks of the thinking processes. This definition, this last definition, is pure computer science angle. So I don't want you to bother on this one until you start your computer science classes. Okay? But nonetheless, I will try to explain a little bit. So it says that it is a zoom in, analysis, and confirmation of the thinking process. So the reason why we are saying this is because programming starts in your mind, it starts in your brain. When you come up with a problem like 2x, it's because you were thinking of a problem and you realize that it follows the function of 2x. Okay, you already have it taught in your mind, so it is a result of your thinking processes. Okay, so once you have these thinking processes in your mind and you think this should be a solution that can be put into a computer as an application, as a software that would automate the solution, so all this process of transferring it from your mind into a model in the computer and all this becomes a process of programming. So it's like you are programming your thinking processes, you are bringing your thinking processes inside the computer. And the reason, and that's why I use the term zoom in. So it's like we go inside our minds to try to find our thinking processes. Then comes the word analysis. So we analyze, we go through, we check, is it okay, does it make sense, and so on. And then in the end we confirm, or we do what we call conformity checks to find out, does it make sense, does it add up, or does it actually solve the problem. So that is programming as well.
Okay.
I hope you are not overwhelmed at this point. You are.
I think I understand some points.
Okay. What? So which point did you understand?
I understand that programming is um, solving solving problems with okay.
It is important that you write the definitions. So
Yeah, I wrote the three. It was like
okay.
the last one.
Okay.
The one I was,
That one you don't have to write it. It's okay.
but I understand the three. The process of writing programs.
Okay. Good.
Then there is the process of automating solutions to problems.
Exactly.
That was the-
Yes. So you
And
understand?
also
Yes. Okay. Continue.
and teaching computers to do what we can do and cannot do.
Exactly. So I think
And
these three are okay, right?
yes, please.
So when you combine them, you can realize that programming is a process of teaching computers what we can do and cannot do at this point. You can see that the third definition is like a sum of the first two. Okay.
Okay.
So, and when we are in this definition, we can see that we use the term program. So you see that we kept on using the word program, and we are actually writing the programs. We are actually producing programs, and that is another question. So if programming is the exercise or process of writing programs, what are programs finally? What are programs? It is very important. So if we say, okay, today we are going to program, it means we are going to take the exercise of writing programs. That's what our definition says. At this point, the definition is still vague and abstract. We cannot really comprehend much until we really know what a program is. What are we going to do? It's like you are sitting there and your boss comes, is like, okay, let's yeah, everybody, let's go. We are going out. Let's enter the car. We are going to do programming today. We are going to write programs. And if you never heard of such thing, you'll be like, okay, what is program? What are programs? What is it that what is it? What are we going to do? Right? So it is important we understand program, and that is what will even make the definitions clearer. It will make it clearer to understand that it is a process. It requires a process. So to understand the program part, we also have to look at our daily routines, how we execute things in our lives. I guess early this morning, before you joined this class, you went through so many stages in your life. Yes. So can we go through them one by one?
What I did when I woke up.
Yes.
So when I woke up, I went to wash my face.
Yes. So let's call it shower.
Pardon?
I said let's call it shower, right? Yes. Then
Then I went to the kitchen to cook.
good. then I'm coming to get my food. So first stage is to even wake up. So the first stage is to wake up. Second one is shower. Third one is cook. Fourth one is
clean.
good. So cleaning. And then anything happened?
No.
Okay. So we can put it like fifth step, join class. Okay. Fifth step, we say class. So thank you for giving us your daily routine. We don't mean to intrude your life, to invade your privacy. So, but at this point, you can notice something. You can notice that it is it takes steps. It goes step by step, right? You notice that there's one step, another step, and so on. And even each one of these steps, let's say the wake up, did not just happen as in wake up. It went through some small steps, sub steps inside it. Because you cannot just wake up like this. Probably your ears started to capture some sound, daddy or mom calling you, saying wake up, or some alarm just ringing, alerting your system, and then your system now just responds, and out of this response your consciousness starts to rise, and then by the time you realize, all the awareness is up and you are up. You just woke up. Are you with me? Dunamis, are you around? Okay, welcome back.
Thank you.
Okay. So I was discussing the various steps. Okay, I was saying that we can realize that it all happens in terms of steps. Okay, it happens in terms of steps, and then I was saying that each one of these steps can even have its sub steps, right? So I was taking the example of the waking up, which might not just happen as in once you wake up. It starts with you hearing a sound, you hearing a noise, you hearing daddy and mom calling you, or you hearing alarm, or you just feeling uncomfortable in your skin, and then just rolling. And by the time you realize, your body's awareness starts to rise, right? And the consciousness starts to wake up. And that's how you find yourself into the state where we call wake up, right? So you see, even each one of these steps we just mentioned can have its own sub steps inside it, but there's a key point to all, which is steps. It goes into steps. Now if we look at the steps aspect, and then we can also look at the fact that you did this today, but tomorrow you might need to think ahead, right, so that you can be able to execute these steps smoothly, because you don't want to waste time. You don't want to be trapped into some situation that will prevent you from missing these steps. So for example, you are having class tomorrow face to face, right? So it will have an impact on how you execute all the other previous steps. So what do you do today? You kind of plan, right? You cannot plan ahead. Very important. So you plan, and you will be like, when you are planning, you are going to greet every single thing. You are going to say, okay, let's say from 7 o'clock, and this is 8 o'clock, this is 9 o'clock, and so on, right? So you kind of grid your day and you'll be like, okay, 7 o'clock is to rise. Are you with me?
Yes, please.
Oh, okay. You nearly got me scared. So you'll be like 7 o'clock rise, 8 o'clock shower, okay,
Mm-hmm.
9 o'clock cook, and so on. Although by 9 o'clock you are in class, but it is an example, okay? So you plan all these various steps, and then when you plan, what happens? The steps will be executed into what we call sequences. So sequentially executed, one, then the other, then the other, then the other, and then the other. So when you put steps into sequences like this, you do what we call plan, schedule, okay, my mouse is refusing to write, schedule. So you did plan, you did some electricity is shocking me here. So you did plan, you did schedule, and you did program. So you just planned or scheduled or programmed. So to plan is to organize steps or organize tasks into steps or into sequences. It's the same as schedule something. To schedule something is to put a certain number of tasks or stages of events into sequences in terms of time. So a program is basically function of time, right? And then steps or stages or tasks to be accomplished, like this. So whatever steps or whatever task you accomplish, there will be function of time. So doing this, whenever you do this, you do what we call planning, you do what we call scheduling, you do what we call programming. So if I ask you, plan your day, or schedule your day, or program your day, this is what you are going to do. So at this point, you can now understand that you have been programming your entire life up to now. Do you agree with me?
Yes, please.
Do you understand that daddy and mommy are also programmers?
Yes, please.
Good. Now, don't go and laugh at them. We are all programmers. Naturally, even from within our thinking processes, within your brain, you keep on programming every single second. If I do this, what will happen? Okay, I should do this so that that happens, so that it will become like this. You plan outcomes. Okay, you plan outcomes every single second in your brain. So that is programming. So in our case, as software developers, our focus is not going to be too large as in programming the whole day. We will go deep into deeper details. We'll go in total. So if we take the waking up, we would like to go deep inside it, into programming it. Okay? So every single problem we'll have, we'll try to break it into pieces and then mount these pieces into sequences. So we'll mount into these pieces into step 1, step 2, step 3, step 4, and so on. So always remember, steps are important because it indicates the timing, it indicates the sequences. Okay, the timing and the order, what happens next after this, and then what happens before what. So that's why these steps are important to us. And when you start learning about algorithms, you realize that we just wrote an algorithm, which is just a step-by-step instructions of a program, okay, or your plan. Are you following at this point?
Yes, please.
Like I say, it is very important you understand the core idea behind it. It's not about the definition being memorized, it's about understanding the core principles. At this point, I want you to have a mental model of what it is like to program or to plan, and keep the understanding in terms of planning your day, scheduling your day, the same term that is used by computer scientists as programming. Okay, so anytime you tell your friends, Charlie, we need to plan this event, we need to plan the end of the year, we need to plan our final year event or celebration, it is about programming it. So the steps to go into a program can vary from one moment to another moment. The proof is, whenever you are planning an event, if you have 2-3 people planning an event, you will see that these 3 people they will plan the event well, but the steps everyone takes to go about the program can vary. And that's what makes the software development field versatile. And one program can be written differently in many ways. Okay, so let's take an example to bring to connect the bridges. Let's take, for example, a problem such as adding 2 numbers. Okay, we'll use a mathematical problem, or should we go with a natural problem? Let's take a more natural problem. Let's say tomorrow you are to go to market, buy food stuff, and then after buying the food stuff, you are supposed to have a family meeting, and then after the family meeting, you are supposed to have a study time. So we have market, right? We have meeting, okay, we have meeting, then we have studies. Okay, so we have 3 elements that are involved so far in our plan. So our first element in this should be market, right? Second should be meeting, and third should be studies. But we can start to ask ourselves some few questions inside, which is, okay, if I go to the market and maybe there is hold up on the road, what happens? So you see, so in step 1, I can have some other sub steps and be like, okay, if I am late, what happens? Postpone meeting or push meeting to a next hour. So push or postpone, right? And then pushing the meeting or postponing the meeting would also mean pushing the studies, right? And then you keep on asking yourself the same question. Okay, what if I go to the meeting and then during the meeting there is something that happened and then the meeting goes too quick or maybe very slowly? it will involve so many things behind that will affect the studies as well, and so on. So all this arrangement of your steps, all this arrangement of the various sequences of your program can be affected by many conditions. They can be affected by many conditions. So all this thinking process, all this arrangement is programming. And now the final result you have, which is all this, if you had it written on a paper, the final result on your sheet of paper is called program. And that is your program. This is our program here, another program here in a different format. Let me use different color. Another program here in a different format. One program here in a different format, solving different problem. So programming is arranging steps or arranging routines into a sequential order. Are we there?
Yes.
So arrange steps, routines, tasks, or activities into a sequential order. Okay. So any questions, any obscurity around at this point?
No.
Okay, so now at this point we have learned that programming is the process of writing programs, and we have seen that a program is actually a sheet of steps or sequential steps showing we accomplishing a task or set of tasks. Good?
Yes.
Good. If you understand this definition very well, you understand what programming is. You understand programming as the process of doing or writing programs, and then the key is understanding the program, what a program is. Okay, is the final result of our plan. Okay, whatever you plan, the final result you get, the final plan itself is the program. Then the plan is a sequence, is an ordered list of steps. It's an ordered list of steps to accomplish the desired goal. Okay, I want you to have that mental model. It is key. No matter how programming is defined, and wherever it is defined, whatever language is used to define it, that is the core of it there. The secret lies in the word program. Okay?
Okay.
Good. So, that being said, right now we just wrote these programs using normal human language. Computers will not understand this language. They don't understand mathematics either, in terms of, yes, plain mathematics like this. They don't understand that. The only thing computers understand is either there's electricity or there's no electricity. Isn't it? Right now, if you unplug your computer, okay, that's if it is plug and play, it will just go off because there's no electricity. And that's what we do when we press the power button. And the power button, you can see it usually has this symbol. Yes, because it is just the composition of this 0 and 1, which says this button will put the computer in the one state, which is on. so on, or in the zero state, which is off. So that's what the computer understands. The same way, if we go deep inside the CPU and where it does all these calculations, it's about turning on some switch, okay, like the switch on your wall, which has some wires like this. So let's say there's wire here, and then it connects to something. So let's say some light bulb here. I wouldn't want to go deep into the electronics part, so I wanted to stay light here. So another circuit here with another light bulb. I know you have many of them in the room. So then you have another switch. Okay, so anytime the CPU does any calculation, it's like it's closing or opening switches, so that some light will go on, on or off, or on or off. So it creates this combination of switches, so many of them, many of the switches, and these switches are handled by an electronic component called the transistor. I don't know if you know of it. Okay, don't worry. That's the electronics part. We don't want to bother right now. We'll have other courses that will discuss electronics. But the core concept I want you to have to understand at this point is that these transistors, they behave like switches, just like the switch you have on your wall to turn on light and off. So the CPU has them in billions or even trillions sometimes. So imagine having, let's say, 10 switches in your room. You can imagine how difficult it is when they ask you go and on the light in the evening. It is going to be tedious. But the CPU has the capacity of turning on a switch, turning on and off a switches, like maybe some millions of times per second. So even it means if you had 1 million switches in the whole Accra, a CPU can turn them on in less than a second, or turn them off in less than a second. So now let's assume whenever the CPU turns the lights on, it tells us it is night, and whenever it turns them off, it tells us it is day, right? So we just did what we call interpretation. So we interpreted these signals, which is on or off, into something meaningful, which is it is daytime or it is night time. Okay, so the same thing the computer does. Whenever the switch is off, which is the zero state, we give it a meaning. Whenever the switch is okay, this is the on state, and whenever the switch goes off, so the switch is on here, we give it a meaning. Whenever the switch goes off, we give it a meaning as well. Okay, so that's why sometimes you hear people say that the CPU understands binary. So the idea is that the CPU knows whether to turn a switch on or to turn a switch off. And when you have so many switches to turn on and off, so it means you might end up having, let's say, if we were to represent these switches with their state, so we can have maybe the first switch is off, the second switch is on, the second switch is on, the third switch is on as well. So you end up having some kind of number of 0, 1, 1. Okay. Yeah. Or it can be like, okay, the first one is on, the second one is off, and the third one is on. Or you can have the first one on, the second one off, and the third one off as well. Or you can have the first one on, the second one on, the third one on. Or even have 3 of them off. So you see, each one of these series of 1 and 0s is what we call binary numbers. So this is a binary number, this is a binary number, this is a binary number. So within the CPU, it is this kind of things: a switch being off, a switch being on, a switch being on, switch being on, off, on, off, off, on, off, off, off. So it's kind of this, and that's why we are saying the computers understands only binary language. It only knows binary language. So it means whenever we ask it to do 5 plus 5, it must find a way to give a meaning to this 5 in terms of switches. So it must find a state of switches and decide to say, okay, this 5 will be represented by the first switch being on, the second and third switches being off. You get the idea? So the CPU will find a way to say, okay, this 5, it has to be converted into 100, and the next 5 will be converted into 100. So the next thing the CPU is going to see, okay, the first number says that the first switch is on, the second one is off, and so on. And then the next number says it is on and off as well. So we want to find out what is the final state. The final state is that, okay, all the first 4 lights are off, right? I'm just saying it in terms of just plain language, okay? All the 4 first lights are off, and then the 4 last lights are off, and then the first 2 lights are on, right? So that could be the final result the computer will bring out. Then it will know that, oh no, human beings don't understand this kind of representation in terms of switches. Let me also find an interpretation to it in their own understanding. Then it will move it and then say, oh, it is equals to 10. Are you getting the point? So there's a translation from a human understanding language to a computer understanding language, and then from the computer understanding language to a human understanding language. Okay?
Okay.
So this is called translation and interpretation. So we do the translation here, we translate, or transformation, and then here we do an interpretation. So we interpret these numbers. Interpretation. Please be taking notes, okay? Use your journal very well. Note every single thing.
Okay.
Note every single thing that will come in mind. It will help one day. Although I want it to be helpful today, but it will help one day. So this is to bring us to the point that since the computer understands only this this language of switches and so on, so how do we program it? It means anytime we want to tell it, okay, tomorrow, just on we want to give it a program that looks like this. So let's say we have a program that looks like 1 0 0 1 1. So we are telling it the first light, turn it on, right? Second light, turn it off. Third light, turn it off. Fourth light and fifth light, turn them on. So this is a program. We could write it very well and give it to the computer. We'll discuss about where we write it and where we give it to the computer later on. So we could well write this and give it to the computer, and it will execute it easily without any problem. So if you are able to find the place where to write it and give it to the computer, it will write it for you. It will execute it and you will see something. But imagine we are dealing with a CPU, or that can run a CPU, let's take it that way, that can understand, let's say 1 2 3 4 5 switches. And in the case we are dealing with, let's say 10 20 60 switches, you see, writing 60 numbers in a particular order like this can be challenging, right? It can be difficult to write and tell the computer, go and do this program. So this first language, which is the binary language, human beings were finding it very difficult to use it and talk to computers. It is very challenging. Okay. So what we did was we found a way of writing it in an intermediate human-friendly language. Okay. So which would be like, okay, on, or let's say we use the term turn on, and then when we say turn on, we'll give it a certain number, let's say 20. Okay, and then we'll be like turn off 30 and 33 and then 11. Then we'll be like blink. So maybe we have this light that can blink. Okay, blink 6 1 and 10, and then let's say 15. So what we are trying to say here is, okay, if we give the computer 10 on 20, it will turn on the 20th light. Isn't that easier and better?
Yes.
Good. Then we say 10 off 33 and 11. So we just write 33 space 11. It will know that, oh, they are asking me to turn off the 33rd line and then the 11th light. That's quite easy and cool than me writing these binary numbers. Then we are like, again, blink 61 and 10 and 11. That's quite interesting, right? So
yes.
This intermediate language was named assembly. Although this is not the true assembly, but that's the idea. So it was named assembly language. So as you are learning programming, even as we are speaking, you can Google it and see. This my Y is crazy. So assembly. It was named assembly. So assembly is a way of turning the binary numbers into something a bit understandable for human beings to write. And whenever we write the assembly, then we need something in between to convert it into the binary, because after all, we are going to use the binary, we are going to send the binary form to the computer. The computer will definitely not understand the assembly. So we convert it into the binary form. That process of conversion is called compilation. Okay, or interpretation.
So from assembly to binary is
compilation, yes.
Okay.
Or interpretation. Interpretation. Okay, and right here you could see the computer also does the interpretation from the binary form to a human understandable form. Like the final results must be interpreted into something human beings can understand. Okay, so when we compile as the assembly, when we write our programs in assembly, then we compile it, or we do the interpretation depending on the tools we are using, and then we get the binary form. Then we submit that binary form to the computer. Then this will tell the computer which switches to turn on or off. Right? But as time goes, it happened that assembly too started to become very tedious and difficult to handle, because the needs of programs are becoming more complex. Programs are becoming complex, huge, and it becoming, imagine you are having 10 on so many of them, and and you have to align many numbers, let's say some 100 numbers in front, to be able to indicate the switches and so on. And sometimes you might want the computer to keep on doing this repetitively. So for example, in our case, if the program runs, it will turn on the light 20, turn off the light 30, and 33, and then 11, and blink 61, 10, and 15, and then it will stop there. So what if we wanted to be doing that every single given hour, let's say every morning or every evening or every afternoon? So how do we tell that? So we might need to use something and say return or repeat. You see, we might need something. So it will keep on adding many of these, and by the time we realize the assembly has become so difficult to handle and hard for human being. It's not bad, but it is just harder for human being again. Okay, so that's what happened. Assembly is still used widely. So many people program in it and use it, and there are some situations where you cannot dodge assembly, mostly when you are doing system development, like you are building operating systems and so on. It will be difficult for you to avoid assembly. Okay, so that's what pushed people to think of another layer of abstraction. Remember last time I told you about abstractions. It is about adding or simplifying something which was already simplified. So it's like another level of simplification, okay, if possible, to another level of complication. Are you with me?
Yeah.
Okay, so we decided that, oh, this looks a bit difficult. What we want to do is, okay, we want a simpler way of saying this same thing. Okay, we will be like, okay, how am I going to invent this language now? So I will be like echo. No, I will use the word print, for example. I don't know why my mouse is doing this. So I'll be like print, and then I'll indicate, let's say 20. Okay, and then I'll be like if evening, or no, if morning, sorry. So if morning, I missed some R here. I need something to help me write faster on the screen. So if morning, then print, okay, print out. So let me use it this way. Print out, because we are going to use a different function, which is the 10 off 33 and 11. So you see, this one sounds a little bit human friendly, and the words we use kind of mean what we want to do. Okay, are you with me?
Yes, please.
Okay, are you tired?
No, please.
Are you sure?
Mm.
Okay, so this brought us to what we call high level languages. Okay, because these languages now, this small thing we just did, can also be interpreted into assembly. Okay, so we can also transform it, compile it into assembly, then from assembly to binary. So we keep on layering and layering and layering and layering and so all this. So in our case, nowadays, what you are learning, you are going to meet these high-level programming languages. High-level programming languages. So some of them you will meet are like the C programming language. Python programming language, and so on. Now, the interpretation of these languages into assembly here does not always happen like that in reality. When we write Python, we don't always have to compile Python into assembly before the computer runs it, okay? Some of these high-level programming languages can be directly compiled into the binary version of it, okay? So depending on how the compiler is written, that's what determines how the compilation process happens. But the key point for us here is to understand how things moved from the binary to we having high-level programming languages. And today, when you start learning these high-level programming languages, you will see that people will be like, oh, this language is compiled and this one is interpreted. Okay, so for example, when you write a C programming language, you will need to compile it before the computer executes it. But when you write a Python language, a Python program, it does interpret it. As soon you run it, and then while it runs, the computer does the compilation. So these kind of languages are called interpreted languages. Okay, you meet these terms often.
Okay.
Yes. So this is what brings us to our language we are going to study, which is Python. So we want to talk to computer, write programs, then we will need to know at least one programming language to do that. And in our case, we chose Python. So do you see the logic, the flow of things up to here?
Yes, please.
Good. So I will probably try to capture this image and share it with you, okay, so that it helps your mental model. So Python is another programming language among many other programming languages, which is an interpreted programming language. It is well known for its simplicity and its ability to deal with data topics. You see, when it comes to data, Python is very good. The language is created really to make processing data easy. And when we are speaking of data here, we mean as in data science, a lot of information, and information in the various forms that need to be processed for intelligence. Okay? Good. So, and I'll use this opportunity to put a bracket and tell you that you will hear terms like data mining, data science, and all these things. So, in data science, people do what we call data mining. Okay. So what it means is, it's like you go to the bush and you go and start digging the ground and start doing what we call mining, right? Gold mining. You are looking for gold, you are looking for diamonds and so on, any other precious stones. So this same process happens with information. When you have so much information, you can go into it and dig and try to find some useful other information you can find that can be useful either to your business, to life, or to even the improvement of computing systems. So that's what data mining actually stands for. Or it is, you can call it knowledge discovery. Okay, searching for knowledge. You go inside some set of data and then you search for knowledge. So that was just a bracket. So now that we have our Python, we still have about 17 minutes or so, right? I think
Yes.
what I'm going to do, since we are meeting tomorrow again, I will leave you these few minutes to go and now complete the remaining steps we have, which is installing Python. And okay, leave the step 4. We'll do that tomorrow when we meet, but try to do this one today.
Okay.
Since because you left it yesterday, that's why I'm returning you to that. I want you to give it a try. So I will send you the link on your WhatsApp. I will not open it here because it's being recorded. So you will go through the preamble. That's okay. This one alone is okay. Okay. Try your best. Find some time and go through it and try to do the installation on your PC. Remember, the installation process is here. So it's just in the introduction here. This is it here. It's not plenty, it's just 8 steps. And I'm sure you might even get less than that if it is well done. Then you can read a little bit of the introduction here, and we'll meet tomorrow to begin with the actual programming. So we saw the programming theoretically. We understood what it involves, what we do when we talk about programming. We understand now. We are now in the field of programming. We are programmers, right? So we need to really program now. So our next step is to do that. Once we have Python installed, look at that. When I'm saying we install Python, what do we mean by even installing Python at this point? So based on our explanation today, what we are talking about is that we are going to install an interpreter, a software that will be in charge of interpreting whatever we write called Python into now the binary version that the computer can understand. So installing Python, what we call Python there is that machine that is in charge of interpreting the Python language into the machine language. You get the point?
Yes.
So it's that interpreter that is called, that compiler that is called Python. Although in the Python case, the language itself is also called Python. You get the point?
Yes.
If we take a programming language like C, the language is called C, but the compilers might have a different name. For example, the GNU C compiler. So you have the language which is called C, but the compiler is called GCC, for example. We have many compilers, but this one is well known. So you see here, the name of the compiler differs from the language itself. But in the case of Python, the language is called Python, and then the compiler too is called Python. That makes it a bit confusing. So when we speak of Python, which one are we talking about? Is it the compiler or the interpreter, since we said it's an interpreted language, or we are talking about the language as Python? So I want you to have that difference in mind. Always when somebody speaks and uses the term Python, you should find in your mind what context you are in and know what the person is talking about, including myself. From now on, you hear me use the word Python. So you should know in this context, we are speaking of the compiler or we are speaking of the language itself. Okay, there are many languages like this that have the same issue, or if it is an issue. For example, PHP. The PHP language is called PHP, and then the interpreter too is called PHP. Okay, to some point, yes. To some point, because in the case of PHP, yes, we have the Zend engine, which is a PHP interpreter, but it is mostly called PHP. So this brings us to the end of today's session and prepares us for tomorrow's session. If you have any question, any challenge, any concern, you can raise it before we close.
No, please.
Are you sure you are not avoiding so that you don't want to prolong the time?
Oh, no.
Okay, mashallah. So please try to do the assignment for me. Today's assignment is just one, it's not hard, so you can quickly fix it. Okay, so on that note, I thank you so much for your time, and may God increase you in knowledge and good health. Until then, meet you tomorrow.